Next, I'd like to start with the log function and go through the same process where I find its inverse, compose to check, sketch graphs, look at domain and range. So the whole deal. If you're feeling pretty comfortable, absolutely pause and try this one on your own and then speed back through the video to double check yourself. So starting with negative log base 1/2 of x minus 3, I want to find the inverse. So I'm going to say x equals negative log base 1/2 of y minus 3. And the first thing that I need to get rid of here when I'm solving for y is the -1. So I'm going to multiply or divide both sides by -1, whichever way you like to think about that. And then after that, I need to get rid of the log base 1/2. So I need to exponentiate with a base of 1/2. On the left-hand side, I get 1/2 to the negative x. That can be rewritten with exponent rules. You could actually turn that into 2 to the x, but I'm not going to, because when you compose inverses, the more you've simplified, the trickier it can be to spot the cancellation. So I'm just going to leave that one. On the right-hand side, the 1/2, log base 1/2 and exponential base 1/2 cancel, so I'm left with a y minus 3. And then all I have to do is add the 3 to both sides. And that should be my inverse function. So f inverse is 1/2 to the negative x plus 3. So that is my inverse function. I'm going to check it by composing. So first, I'm going to plug this exponential I just found back into the original log function. And I will get negative log base 1/2 of my inverse function minus 3. So it's never a bad idea to throw parentheses around whatever you're plugging in, but this is another one where it looks like I don't end up needing them, so I'm going to get rid of them. Needing them means you need to distribute something through. There's a multiplication attached. There's an exponent attached maybe, which you can't distribute, but you would have to deal with, or some other function. But if it's addition, subtraction, you should be okay as long as there's not a negative to distribute. The first thing to go here is going to be the 3's. I'm adding and subtracting 3, so those will cancel. The next thing to go should be the log base 1/2 and the exponential base 1/2. So when this cancels out, that negative x comes out of the exponent, and I'm left with the opposite of x, which just gives me x. We are supposed to think about domain here. So in order to have any chance of surviving a composition, you have to survive the inside function. But the inside function here has a domain of all real numbers. So we're not going to have any problem surviving that first function. From there, whatever we get has to survive the log function, the outer function. The domain of the outer function, we need x minus 3 to be greater than 0, which means x has to be greater than 3. So we need that exponential function to always be greater than 3. If we're thinking about this exponential function, we'll have to sketch it later, but we're starting with a 1/2 to the x, exponential decay. We then flip it over the y-axis. So we're now looking at, this is very rough, but exponential growth, something like that. And then we shift it up 3. So now we have y equals 3 and we have an exponential growth function going up from there. So we are always going to get y greater than 3, which means when we plug that y into our log function, we'll be in great shape. We are meeting the domain. So this is true for all real numbers. Basically, the inverses, you will compose them and get back what you started with, no matter what you started with. Okay, now we need to go the other direction. So now we're plugging the log, negative 1/2 log of x plus 3, x minus 3, into the exponential. So there's our function. We're going to plug it into f inverse. F inverse is going to take that and it's going to raise 1/2 to the opposite of that. So there's two negatives that show up, one from the function and one from the inverse. And then in the end, we'll add 3. This time, the first thing to go are the negative signs. We multiply -1 by -1, we get 1, and we're left with 1/2 log base 1/2 x minus 3, and then all that will be plus 3. The exponential and log, both base 1/2, will cancel, so we're left with x minus 3 plus 3. And the 3's will cancel, and we're left with x. In terms of domain, we're starting with the log function, so it doesn't have a chance of surviving the composition unless x is greater than 3. Whatever we get out of the log, we are then plugging into an exponential function, and exponential functions don't have any domain problems, so it doesn't matter what we get back, it will be just fine. So the only thing we need to worry about here is the fact that we need an x greater than 3 in order to make it through that first step of plugging into the log function. Last thing here is that sketching practice. I already did kind of a rough sketch above, so I already know that the asymptote for the exponential is going to be at y equals 3. So that was 1/2 to the negative x plus 3. So we got that. We can follow a couple of points. 1/2 to the x would go through 0, 1, and 1, 1/2. Or I kind of like it better. Let's do -1, 2. 1/2 to the x goes through -1, 2. So if we flip across the y-axis and then shift up 3, the flip won't move that first point, but shifting up will. It'll end up at 0, 4. The second point, when we flip, it will end up at 1, 2, and then when we shift up, it will end up at 1, 5. So 0, 4, and 1, 5, and up above I already kind of followed the shape, so I know I'm expecting an exponential growth shape that starts above that y equals 3 asymptote. For the log, let's switch colors again, we have negative log base 1/2 of x minus 3. So that is flipped over the x-axis and shifted right 3. If we think about this one, starts with a vertical asymptote at x equals 0 and points at 1, 0. And then what would the other one be? We could do 1/2, 1. Or we could do, if we want to match above, we could do 2, -1. Let's do that. So we're going to flip over the x-axis. So just for my general shape, I'm expecting that. And then we're going to shift it to the right 3. The vertical asymptote, flipping doesn't affect that, but shifting it right 3 makes it land at x equals 3. And then the point 1, 0, when we flip across the x-axis, that doesn't move, but when we shift to the right, that ends up at 4, 0. And the point, what did I decide? 2, -1. When we flip, it ends up at 2, +1. And then when we shift to the right 3, it ends up at 5, 1. And again, if you follow similar points, the points that match up on the function in the inverse, you'll get similar points. And this, we expect it to be the flipped shape, so it's an increasing log function when we're all done, so it should be something like that. And again, I do see those pairs, the 0, 4, 4, 0 pair and the 1, 5, 5, 1 pair. So that's looking really promising. The domain of the function was all real numbers. Oh, hold on, I'm backwards. The function was the log. So let's go back to purple since I did that here. So for the function, the domain was x greater than 3, and the range was all real numbers. For the inverse, the domain was all real numbers. That's the exponential. And the range was y greater than 3. I think I said that up above and wrote the wrong thing, but maybe not. It's x greater than 3. Okay, so there's the full process. So again, we've already done all the pieces of this, but this makes us practice a lot of things. There's a lot of log properties and simplification stuff that happens when you compose. There's solving, there's sketching, there's domain. So try and think through all those things carefully and use this as good practice. Thanks for watching.